Kinematics is a descriptive study of how objects move. We're not trying to describe why they move, but simply describe their motion. So we'll be talking about things like position, velocity, and acceleration. So the first thing to talk about is position. And in order to talk about position, we need some reference system. It doesn't make sense for us to try to state where an object is if we don't have a map of sorts or a coordinate system for describing where those objects are. So I've put a piece of graph paper out here. We could just pick a point and say, I'm going to make that point a point that we're going to call 0. And everything to the right of that point, we're going to call that the positive direction. And everything to the left of that point, we'll call the negative direction. This is a coordinate system. Now we can make this more complicated. We can also say, I'm going to call up positive and down negative, and we'll call this the x direction, and we'll call this the y direction. These are all just different coordinate systems. When we're working in 1D kinematics, we'll only deal with a vertical or a horizontal coordinate system. Now say for instance we're working with a horizontal coordinate system, and I want to describe this object right here. Well, if we've chosen every box to be 1 unit, say 1 meter, I can describe the object's position as 1, 2, 3, 4, 5, 6, 7. 7 units to the right of 0, or in this case, positive 7 meters. Likewise, an object right over here would be at a position of negative 4 meters. Now, a world in which all objects are static is not a very interesting world. So what happens if my object, which was at positive 7, travels to a position of negative 4? And it does so just in one fell swoop, one stretch. There are two ways we can talk about that. We can talk about its path length. Path length is a synonym for distance. So distance is described as the path length that an object travels along. We can also talk about that object's displacement. Displacement is simply the difference between starting and ending points. So if we want to calculate the displacement, in this case, what we say is the difference between the starting and ending points, or the change in the difference in positions, is equal to the final position minus the initial position. So in this case, the final position is negative 4. The initial position is positive 7. And so the displacement of this object in going from positive 7 to negative 4 is negative 11 meters. What that means is, when all was said and done, the object moved 11 meters to the left. Well, note, it's very important that I said to the left, or in the negative direction. What that means is direction matters, and also, presumably, the 11, or size, matters. So we know that the displacement of an object is a vector quantity. Now back to the distance. That's the path length. So in this case, the path length is 11 meters. And so we would say the distance is 11 meters. You notice a fundamental difference between these two quantities. Distance doesn't seem to care that you traveled in the negative direction, whereas displacement does. So therefore, distance must not be a vector. It's a scalar quantity, not caring about direction. So if we take a look at the opposite situation, let's say the object goes from -4 to +7. What would the displacement be? And how would that compare to the distance? Yet another example would be the object that starts at -4, travels to 0, turns around, goes back to -3, turns around again, and goes back to 0. What would be the displacement? Well, the displacement is still the final position minus the initial position. And so the displacement for this example would simply give us 0 meters minus -4 meters for a total of +4 meters, or 4 meters to the right. What would the distance traveled give us? Well, the distance is the path length. So the object traveled 1, 2, 3, 4 units, 5, 6, 7 units, 8, 9, 10 units. And in this case, the distance is simply 10 meters. So it's very important that you understand the difference between distance and displacement, because they are fundamentally different quantities. So take a look at this question to test whether you understand the difference between the two. An object goes from one point in space to another. After it arrives at its destination, its displacement is, and we want to know the comparison to the distance it traveled. Consider that displacement is the difference between the ending point and the beginning point for an object, and distance is the total path length traveled. Consider that difference between those two quantities and see what you get for an answer. So taking a look at another example, let's say you wake up at your house one day. So here you are at the front door. You walk over to your friend's house. You knock at his door and ask him if he wants to play. He says sure, he's got a new video game. And so you guys decide to play the video game. However, any good video game session requires that you have some candy. So you turn around and you walk to the grocery store, pick up some candy, and you walk back to his house. The question would be, how do your displacement and your distance traveled compare? Well, what is your displacement? Your displacement, or your change in position, being final minus initial position, starts with initial position being, well, if we call your friend's house a position of 0, and your house is 2.1 miles away, we'll call this 2.1 miles. Where do you end up? You end up at 0 miles. So your displacement is simply -2.1 miles, where the negative indicates you ended up 2.1 miles behind or in the negative direction relative to your house. What was your distance traveled? Well, your distance traveled is going to be the 2.1 miles over which you walked to get to your friend's house, the 2.1 miles back, so now we're at 4.2 miles, plus the 4.3 to the store from your house, so now we're at 4.2 plus 4.3, or 8.5 miles, and then another 6.4 miles back, so 8.5 miles plus the 6.4 miles back. That's going to give us 14.9 miles. What's a way that we can relate displacement to distance traveled? Well, it seems that individual displacements are related to distances traveled as long as we're not changing direction. So let's say the trip from you to your friend's house is one trip. The displacement for that first trip is going to be -2.1 miles. The displacement for your second trip, where you go from your friend's house to the grocery store, is going to be 6.4 miles. The displacement for your third trip, or the grocery store back to your friend's house, is going to be negative 6.4 miles. Well, if we look at what the distance traveled was, we know that's 14.9 miles. If we look at these displacements, I know to calculate the total displacement, I would just add the three of them together. But how do I get the distance? Well, if I take the absolute value of each of these, and I add each of those displacements together, or their absolute values, I get 14.9 miles. The trick is that you need to separate the displacements according to changes in direction. So once you change direction, displacement and distance start to diverge in terms of quantity. So if I just separate each segment of travel and eliminate the changes in direction by taking the absolute value, I will get back to the distance traveled. And that's the way that distance and displacement can connect in a given problem.